What's wrong, Amber?
Going to solve the homework. I have nothing.
Sorry, we have another lesson to do. No, please, I'm hearing too much swearing in here, okay? Keep it clean. You know, this isn't biology classroom. This is maths classroom. We keep it clean in here, okay? You can save everything like that for biology class, all right? Yes. Okay.
Do you guys swear involved with that?
No. Next topic we're going to look at is long division. Long division you would have done, of course, with numbers in elementary school, but now we're going to look at long division with functions, quadratics and cubics and linear, okay? So I'll give you the process. Some people get very confused on this, so I need you to start writing notes. I'll try and go as slow as I can. But as an example of how long division works when you have functions, I'll do 1a here. So x minus 2 into 36x cubed minus 59x squared minus 25x minus 2. You got a question, Amber?
No.
No, good. So be quiet, please. Thank you. Now, I'm going to show you the long division process here, okay? So please, if you've not seen this before or you're confused by this, watch carefully, okay? Oh, always. Okay, so firstly, what you do, you look at the first term here, and then you look at the first term here, and you ask yourself, what do I multiply x by to change it into 36x cubed? And the answer is 36x squared. Good. So firstly you write down 36x squared. Now, write that down. We'll try and go nice and steady here. So if you want to think of it as a process, your first step you might want to call is E for estimate. You roughly try to get this to match this. And the way you roughly try to get it to match is by matching the first terms. Next step is to multiply. So what you do next is you take your answer here and you multiply it by both these numbers in front. So you take the answer up here and you multiply it by both of these. So multiplying, you get 36x cubed minus 72x squared. So now your choice becomes clear, because now you've made two the same. That's always what you want. You always want them to be the same. So that's the multiplying step. The next step is the subtraction step. So what you do is 36x cubed minus 36x cubed, gone, 0. Then you do minus 59x squared minus 72x squared. So that's that 13x squared, is it?
Yes.
Yeah? 13x squared. That's the subtraction step done, right, isn't it? What?
Can you repeat that? How did you get 72?
36 times 2. Question? Yeah, it's minus 59 minus 72. There's like a big minus here. Yeah. Okay.
Is that a root or
What?
the thing that the
This thing?
yeah, it's
not.
No, that's a long division sign. Have you seen them before? I think you would have. Maybe a long time ago. And maybe you write them upside down or with a curved bracket.
Yeah.
Do you do it like something like this?
No,
Like this?
I know.
Yeah, like this.
Oh, well, in that case,
Oh yeah.
Now I understand.
oh, yeah, now I understand, yeah. All right, okay. So we've done the subtraction, and then the next step is carry down. So what I mean by carry down is this piece at the end here. That gets carried down. Minus 25x minus 2. And then what happens is the process starts all over again. So you go back now to the e. So once again, you look at the first term, but now it's down here. You're starting again down here. So let's see, put it in a yellow again. So I look at the first term here, and then I look at the first term here. That's yellow again. Yeah. And then you say to yourself, what do I multiply x by to make 13x squared? 13x. That's done. Now we multiply. So 13x times x is 13x squared. 13x by 2 is minus 26x. So that's the multiplying done. Now we subtract.
0.
So 0 again, and then minus 25 minus 26 is 1. So 1x. And then after subtract, what we do? Carry.
Carry.
So the only thing left to carry down is the 2. Now this is really nice. What number do you multiply x by to make x? 1. So all you have to do to finish is put a 1 in. 1 times x. X. 1 times minus 2. Minus 2. And you subtract and you're left with 0. You don't have to get 0 at the end. It's just nice when you do. And does anybody know the name of this number at the end? Yeah, very good. It's called the remainder because it's what remains.
If it's 0.
That's fine. That happens. Yeah, that's fine. No, it's not easier. I don't like this other method. This is, no, I don't like this. I don't like this. I know what you're talking about. We won't discuss that in class. If you have another way to do it and you like using that way, go ahead. Okay? But this is my preferred way. Write it down, come on. Shh. There's no need to talk. And if you have a question, you can ask me. Yes?
If it was x minus 2 over x plus 2, then it would have been 1.
Yes, it would. It would have remainder. Yes.
Then remainder would have been 1.
Well, I'll try and do one with a remainder, maybe. Yeah. H, maybe. Yeah, well. Maybe H.
So which one do you do now?
Well, hang on. Wait. Okay. Shh. No, what's the problem? Guys, if you have a question, just ask me, or you can't see. Alright, I'm going to do another example. Next one. Hurry up. Psst. Mona. Come on. Slide it down. Pass it down. Thank you. Now I have 2.
Kindergarten.
Just like that, yes. Okay. You're sitting way too close to the teacher to get away with that, all right? And well, it doesn't matter, because even Ahmed down the back, I still got his phone, okay? No, middle I can still see all phone activity in the middle. Okay, another example now. So I'll do 1h as an example. And it's a little bit more difficult because now, instead of just an x, you're dividing with a 7x. Okay, so another example. So you have 7x minus 7 divided into 35x cubed plus 7x squared minus 35x minus 6. The process is exactly the same, just a tiny bit more difficult, but not much more difficult. So you start off with asking yourself again, what do you multiply 7x by to make 35x cubed? And the answer is 5x squared. Then you do the multiplication, and you get 35x cubed minus 35x squared. And then you do the subtraction. They go. 7 minus 35 is 42x squared, and then carry those down. So that's the first part done. Now we start again. What do I multiply 7x by to get 42x squared? 6, isn't it? So here you get 6x. Then you multiply. So you get 42x squared minus 42x. And then you subtract. 35 minus 42 is 7x. 7x, isn't it? No.
77.
7x. Oh yeah, it is. 7x minus 6. And then to finish, what do I put up here? Plus 1. So now I multiply 7x minus 7, and in this case, they don't cancel. I have remainder, let's see, minus 6 minus 7, that's 1, isn't it? So remainder is 1. Okay, write that down, please. Stop talking, please. If you have a question, just ask me.
Sure.
Yes.
The next step.
Yep.
How did you get minus 35x?
That's carried down from above 35x. See? The 35x. These go down. They're here.
Yeah.
5 times 7. You know this.
Yeah.
Another example?
It's really hard.
This kind of for question 1 is hard.
Nice.
Now, I give you a bit of vocabulary, okay? If the remainder is 0, so here's some vocabulary. If the remainder was 0, we call 7x minus 2 a factor. Now, in this case, it's not a factor. Although in the last case, because the remainder was 0, we could have called x minus 2 a factor. But not in this case. So 7x minus 7 is not a factor. Do I need to scroll down? Yeah. Oh, and just since I'm giving you vocabulary here, the piece at the end is called the factor, and then the answer you get on the top is called the quotient. This is a word you'll see again in semester 2. Quotient is the result on the top, remainder is the result on the bottom. Okay, if you look in your book, I won't do an example from number 2 because all I'm asking you for in number 2 is to tell me if it is a factor, which is another way of saying do the long division and tell me if there's a remainder of 0 or not. So what I want you to do in number 2 is long division again. And then you can decide if it's a factor or not. But number 3 now, I'll do an example from number 3. Yes? Okay. What was that?
No, just so you time.
Okay. I thought I saw something. I couldn't be sure though.
I thought I'm a while ago.
No. I just about didn't see it. Right, number 3 here. So, if I ask you 5x cubed minus 12x squared, this is 3a for example, plus 7x minus 6 all over x minus 2. And I ask you to simplify it. Now that looks really complicated, but actually it's not really, because when you think about it, all a fraction really is a division. So I can rewrite this like this. Oops. It's a fraction, but fraction is just division. So like 4 over 2 is the same as 4 divide 2. So now you realize this problem of simplifying can be changed into a long division. So if I do the long division now, I'd have x minus 2 dividing into 5x cubed minus 12x squared plus 7x minus 6. Okay, let's see how quick we can do this. So firstly here, be 5x squared, and here would be 5x cubed minus 10x squared. Squared. I subtract, and I get minus 12 minus 10. That's minus 2. Carry those down. Next one is minus 2x. So here is minus 2x squared plus 4x. I subtract, and what do I have left? 3x minus 6. And to finish, plus 3. And then I get 3x minus 6 all over 0.
Factor.
It's a factor. So you know that this is equal to 5x squared minus 2x plus 3. Now I have something else to say about that, but just for the moment write that down.
So, it's always for 3 steps here.
Yeah, there should be a quadratic on the top, yeah. This is 0 there. Clean this up a bit. Okay. It's a factor. I want to look at an example that's very similar to this, but with numbers. So I'll just scribble it up the top here. Okay, so suppose, for example, I said simplify 11. Well, no, I should really go to a new page. Can I go to a new page? I'll give you a few more seconds. Oh, what else do you need to write down? The top or the bottom? You need to get the bottom part. Okay. Yes.
If it is 0, it's called a factor.
Yes.
And if it's another number,
We just say it's not a factor. There's no special name for it.
but in general, it's reminder. Factor reminder.
Oh, okay. The number at the end is called remainder. So here I say the remainder is 0, the remainder is 1, the remainder is 2.
Remainder is 0 to be factor.
Yes, if the remainder is 0, I say x minus 2 is called a factor. Yeah. And if the remainder is not 0, then I say x minus 2 is not a factor. Okay, new page now. So I want to do this again, but with numbers, to show you an important requirement for this method for simplifying. So suppose I ask you to simplify 11 over 2. What did we do first if we're imagining the last example? What was the first thing I did? The long division. Yeah. So you would say 2 into 11, that's 5 times. 5 times 2? 10, and the remainder is 1. So if I said 11 over 2 equals 5, of course we know that's wrong. But why is it wrong here?
Because there's a remainder which is not 0.
Yes, exactly. And that's it.
It's not a whole number.
Exactly right. The technique I just showed you here only works if the remainder is 0. If you got a remainder here, it's not 0, then this here would be false. Okay, now in semester 2 we'll see what do we do when that happens, but that shouldn't happen in this semester. So you should get factors here. The remainder should be 0. Otherwise you can't do question 3.
You can get to 0, but it has to be 5 1.1 over 5.
Yeah, but that's not... I did this example to illustrate, not to,
Okay.
you know, like...
I remember that.
No. I suppose don't think about decimals. You're missing my point if you're thinking about decimals. Decimals do not exist today, okay? Everything is a whole number, all right? Okay, I'll do another example now. So, that's 1, 2, and 3. So now look at 4. Okay. Look up. So, no, just listen. I need quiet. You need to listen. Okay. So my question is, I want you to factorize this, meaning that I want you to write the 3 brackets, the 3 linear terms you need to multiply in order to make this cubic. I don't remember if I told you the name of this, but these equations are called cubics. I realize I said that a couple of times. So we have quadratic and we have cubic. Now, it's really difficult to do, but it's made a lot easier if I give you one of the factors, which I do if you look at the question. I tell you that x plus 1 is a factor. Okay? So I tell you here that x plus 1 is a factor. So you really only have to find 2 factors here. This one and this one. Okay? So how can we do that? Well, let me just rewrite this again on one line so I can fit it in. I have 9x cubed plus 14x squared plus 9x plus 4 equals x plus 1 times something else. Might be 1, might be 2, I don't know. There's other things here that multiply by x plus 1 to make this, and I don't know what it is. But if you think back to question 3, what you could do is divide this underneath here, right? And then this division here gives you exactly what you're missing for. And we know what this is. This is just a long division. So by doing a long division, we can get the missing factors. So we do the long division next. So x plus 1 dividing into this, 9x cubed plus 14x squared plus 9x plus 4. So we'll see how quick we can do this. So here, 9x squared, so this would be 9x cubed plus 9x squared. Subtracting, I'm left with 5x squared plus 9x plus 4 plus 5x. So 5x squared plus 5x. I subtract them. What am I left with? 4x plus 4. What do I need here? A 4. And I won't even bother to finish, because when I multiply by 4, I get 4x plus 4, which makes a remainder 0. Although I expected to get a remainder 0 because I knew x plus 1 is a factor, because I told you x plus 1 is a factor. So I was expecting to get remainder 0 here. So what exactly is the answer here? What is the part now that I pick that is the piece I don't know? It's the term up the top, this term here. So now I can go back to my original question and replace this here with 9x squared plus 5x plus 4. And if this quadratic has factors, I can factorize it again. Although I think if we do a quick check, b squared, what's b squared here? 25. And 4 times a is 36. 36 times 4, what's that, 144? So 25 minus 144, positive or negative? Negative. So does this have any solutions? No, so I won't even bother trying to factorize it, because I know it doesn't have solutions. And if you were to check on your calculator, you'd see that there'd be no solutions, okay? Now, sometimes you have factors here, sometimes you don't. In the exam, again, sometimes you do, sometimes you don't. If you did, then there'd just be one extra step where you write the two factors in. By the way, let's imagine that this had only one factor. What would you write in? Would you just write in the one factor? So let's just, okay, this isn't it, but let's just pretend for a moment on our calculator the answer here was x equal to 1. So that means you have x minus 1. And you only have one answer.
So
Yep.
the factor will be the same the question, the same formula.
For what? Oh, for this? Oh yeah, you can use the previous formula, yeah.
No, I mean I have the other factor, because all numbers can divide by the same number or one.
Oh, sorry, I think I know what you're saying. Just listen to what I'm about to say and you can tell me if it makes sense to you. Let's just pretend for a moment that this quadratic had only one solution. And let's pretend the solution was x equals 1, okay? So that means the factor is x minus 1, but that's not quite right, because you should have 2 to make a quadratic. So what was the other one going to be? That's it, very good, perfect, yeah. That's what you were saying, yeah? Yes, exactly right. So if you have only one factor, it's not really 1, it's just the same one twice, okay? So anyways, my point I'm making at the end here is you should really have two situations. A linear and a quadratic, or a linear, and a linear. And it is perfectly fine if these two are the same. Okay? Now, I think I'll do another example of this, I think, and then we'll do one from number 5. So write this down, please. I'll do one that has what I was just talking about. So, yes. Do you want to see an example that has, this one has no factors at the end in the quadratic. I can do one with 1 or 2 next, which sounds more difficult or confusing. 2? Because it's bigger?
Is it not factor?
Yeah, well what I'm saying here at the end is this quadratic here has no factors, no solutions. I realise the words might be getting confusing. Okay, sorry, let me say that again.
But
This quadratic here has no solutions. I can't break it down anymore. Remember, we did a worksheet on factorizing where you find the two factors?
yes.
Yeah. I'm saying this doesn't have two factors here. Because the discriminant is negative. If the delta is negative, it definitely has no factors. Definitely. I will do I'll do the next one. I'll do B. Okay, I'm going on to a new page now. Come on. Okay, now I'm going to a new page. If you don't have it taken down, you'll have to get it from your neighbour. Okay, so same deal. I say yes, okay. Example, 49x cubed minus 77x squared minus 45x plus 81. I want the three factors, and I tell you one of the factors is x plus 1. So, what are the other factors? So, it's like the last one. What do I do first? Divide by x plus 1, and that gives me my answer. But when I divide by x plus 1, that's just a long division, isn't it? So, long dividing by x plus 1 will give me my answer. So, up here I get 49x squared, so that's 49x cubed plus 49x squared, and then I subtract minus 77 minus 49. What's that? 50, so minus 126? Yep, alright. Minus 126x squared, carry those down. Alright. Next number is minus 126x squared.
No,
X, thank you. Minus 126x squared, minus 126x. Subtracting, I get 55, 65, 7, 81 x plus 81 to finish plus 81. So here I get 81 x plus 81, 0. So these are the missing factors. But can this be simplified? Can you factorize this into two smaller factors, two linear factors? Well, if I do check here, b squared will be a very big number, minus 4ac, so it'll be positive, possibly 0. Did anyone calculate the discriminant here? Oh, your calculator's in an annoying mode. Give me that one.
0.
It's 0, is it?
Yeah.
So the delta is 0, which means there should only be one solution. But you could factorize this. 7x minus 9. 7x minus 9. 7 times 7 is 49. 9 times 9 is 81. And then you have 49x. No, sorry. Minus 63x minus 63x minus 126x. So the answer is, the factors are x plus 1, what's the other one? 7x minus 9 and 7x minus 9. They're the three factors. The first one I give you, and the other two you get from your answer after long division. this will be a typical, very typical exam question, this one here. This would be an example of a section B question, a longer question. It'd be part of a long question. Whereas 1A would be a section A short question. Okay, in a moment I will do 5A. Okay, 5A now. Sorry, Amjad, you'll have to copy it.
Just
Go down. It's just the 3 factors at the bottom.
okay, I got it.
All right. Okay, last one now. I want you to simplify x squared minus 1 all over x minus 1. Now the reason, I know there's other ways of doing this and there's special rules and all that, but the reason I have question 5 here is to show you that long division is really good, even in situations where it looks like it wouldn't work because you have more than one variable, where you have x and y. So like for example, actually maybe I'll do a more difficult one, like in C, where you have x squared minus y squared all over x minus y. And in fact, long division will work here as well. So let's have a look here. Amr, you're not paying attention now. Okay. So if we follow the process, what do I multiply x by to make x squared? Well, the answer is x. That's fine. So let's multiply x by x squared, x by y, minus xy. Now this is where you subtract, and the subtraction doesn't quite, well, I mean it works. Here they cancel, but here they do not combine because they're different, a y squared and an xy, okay? So what you need to do is just write down minus y squared plus xy. They don't combine together because they're different. Now, this is where the trick comes in. And this is, long division is quite flexible like this, because you might say, right, next, what do I multiply x by to make y squared? Well, you can't, can you? Like, you can't change x into y squared. That's too much of a stretch. Although, you can easily change x into xy by multiplying by y. And the point in this question is that you don't have to make the first term match. I'll say that again. Listen carefully. You do not need to have the first term to match. You just need one of the terms to match, and that's it. So here I'm matching the last term. Now when I multiply y by x, xy, yeah, and then y by minus y, minus y squared. And if you subtract them, you have an xy and a minus xy. They're gone. And a minus y squared minus minus y squared. It's gone, 0. So the answer here, x squared minus y squared divided by x minus y equals x plus y. And for those who can think back to middle school, if you were to bring this x minus y up to the right, what formula would you have there? What's it called? Anyone know in English? Difference of two squares. You might have seen this formula in middle school. X squared minus y squared equals x plus y times x minus y. Yeah? No, you don't need to do that part. There. Yes?
When we multiply x to y,
Yeah?
square, we get xy. Why we didn't get
Are we talking about the x multiplying or the y multiplying?
No, the x multiply.
This one. X by x is x squared, yeah? And x by y is xy.
Okay.
Yeah? Okay, write that down, please. So what I would like you to do is 3 from each. And you can make it the last 3 in each. Last 3 in each. And you can start it now.
No,
No, don't worry, I'm just stopping.